Let's keep looking at Pascal's law, and I want to show you a handy-dandy trick for figuring things out that hopefully is not too painful. So you remember in the last video we looked at Pascal's law, how pressure in a confined space acts equally in all directions. So if you've got 100 pounds of force coming in the top, that 100 pounds of force acts on every single square inch. Each square inch has 100 pounds of force. So if you have a bottom that has 20 square inches in it, every one of those inches has 10 pounds of force. 10 times 20, that bottom has 20 pounds of push on it. 10 pounds per square inch gives you 200 pounds of force. So pounds per square inch. PSI stands for pounds per square inch, and you might think of PSI as a handy memory device to remember how this formula goes. PSI, pounds per square inch. You see that written on the sides of tires, for example. You might look at a car tire and it says this tire should be inflated to 35 psi, for example. Okay, pounds per square inch. Pressure in psi is force in pounds over area in square inches. Pressure is pounds per square inch, PSI. And I think if you just say PSI to yourself, that will clue you in maybe to remember this formula. Pressure is pounds per square inch. Here's that tool I told you about. So you notice how in this formula, pressure is pounds per square inch. There's a thing up on top of the fraction and a thing on the bottom of the fraction, and then another thing by itself. If you make yourself a triangle, as I did here, you can take that thing on the top, force, and put it in the top of the triangle, and then take the other two and stick them in the bottom of the triangle. And it doesn't matter what order you put them in the bottom of the triangle. I put them in this order. So there's that triangle with our pressure equals pounds per square inch stuck in the three corners of the triangle. This triangle is called a Mueller diagram, not that you need to remember that. And anytime you have some formula that has three terms in it, you can use one of these triangles to help you figure things out. If you're working with electrical stuff and you want to think about volts, amps, and watts, you use this triangle. If you're in hydraulics and you want to think about figuring out pressure and force, you use this triangle. So they're really handy. And so you put the term on the top of the fraction in the top of the triangle, and then the horizontal line tells you that's where you would divide. The vertical line tells you that's where you would multiply, and I'll show you in the next slide what I mean by that. So what you do is, if you're looking for one of these terms, you cover up the one that you don't know, the one you're looking for, and the other two will tell you what to do, either divide or multiply. I'll show you some examples. So let's say you're trying to figure out the pressure. Okay, you take your finger and you cover up the pressure. That's the one you don't know. And what are you left with? You got an F on top and an A on the bottom. Oh, looks like you've got a fraction. If you're looking for pressure, you go force divided by area. And we just saw that formula. Pressure is force over area, or pounds per square inch. Okay. What if you're trying to find the area? You know the other two. No problem. Cover up the A with your finger. That's the one you're looking for. And what are you left with? an F above a P. Force divided by pressure. If you're trying to find area, you go force divided by pressure and you'll have it. What if you're trying to find force? Well, you cover up that one. That's the one you don't know. And now you're left with two things next to each other on the bottom. That tells you, oh, you're going to multiply those two because they're sitting next to each other. So if you're looking for force, you write pressure times area. And here are the three different ways you could arrange that formula arrayed around this triangle, just to be cool. So let's look at an example. Let's say you've got this cylinder, and you've got 400 pounds of force on the end of the cylinder rod pushing on it, and it's pushing on a piston inside the cylinder that's 4 square inches of area. Okay, how big is the pressure inside? Well, using your handy-dandy triangle, you cover up the one you don't know. You don't know pressure. So you are left with force over area. 400 pounds of force over 4 square inches of area looks like your pressure is 100 psi. And what you would do is you would pick up your calculator, of course, and you would punch in 400 divide by 4, enter, and that would give you your answer. Okay, let's switch them around. Now you have a system where you know the pressure, which you often do. The pressure in the system is 100 psi, 100 pounds per square inch, and it's pressing on a piston that is 4 square inches in area. The question is, how big a force can it lift, or can it push? So you're looking for force. That means the force is the one you cover up with your finger. What are you left with? You're left with a P and an A next to each other. So that means you're going to multiply P times A in order to find the force. P, the pressure, is 100 psi. Area is 4 square inches. So you just found out that you could, with this system, lift or press 400 pounds. And again, what you would do in your calculator, you would punch 100 times 4, enter, or equals, and it would spit out 400. Well, our first assignment it's relatively short, I hope. It has 4 problems that look something like this. So for example, let's think about something like this. So here's a hydraulic cylinder. It's got a 100-pound weight pressing down on the piston, and the piston is 4 square inches in area. The question is, how much is the pressure in the system? Alrighty. So you are looking for pressure. That means you cover up the P. That's the one you don't know. And what are you left with? You've got force on top. You've got area on the bottom. Force over area. Aha! Pressure is force over area. Pounds per square inch. 100 pounds divided by 4 square inches looks like you've got 25 psi of pressure in here. Let's look at a different one. I know the drawing looks the same. I did the old copy and paste deal with my drawing. So on this one, we know the system pressure. They tell us that the pressure is 100 psi coming in here. And that 100 psi is spread over a piston that has an area of 10 square inches. The question is, how much force can this cylinder lift? All right. So we're looking for force. That means we cover up the F. That's the one we don't know. And we are left with a P and an A next to each other. That tells us we're going to multiply P times A. Force, it gives us pressure times area. Force, in other words, is going to be 100 psi times 10 square inches. We're going to have 1,000 pounds of force. 1,000 pounds we can lift. And I just want to say a word for those of you who have had math class already. Some of you have. I know in math class they do a lot with making sure you get the units right, the pounds and the square inches and the psi. You'll notice that I did not put all those units in there because I'm trying to keep these slides clean so that you can just focus in on the numbers. I hope you don't mind that I did that. And in the assignment that you'll find in Moodle, I do write the units, but you're welcome just to look at the numbers and punch the numbers into your calculator. So I hope you find that triangle helpful. But be sure to talk to each other or let me know if it bugs you.